let's consider this ball right here. This ball is matter. Matter can be subdivided into atom. Atom can be subdivided into subatomic particles, proton, neutron, and electron. But those subatomic particles can be subdivided even further, and this is known as quarks. And what quarks are basically what we consider the fundamental particle that consist of all matter. And these quarks can be explained by certain charges. And the two stable charges, or the main charges we use for quarks, are known as the upcharge and the downcharge. The upcharge has a positive 1/3 charge, and the downcharge has a negative 2/3 charge. So when we look at the quark structure of a neutron, we can see that the neutron had two up charges, totaling a positive 2/3 charge, and one down charge, which totals a negative 2/3 charge. And we add those together, that gives you a total of 0 charge. And that is why a neutron has no charge. Now we've talked about the 4 fundamental forces: gravity, electromagnetism, strong force, and the weak force. Now we can talk about the unifications behind those. As I said earlier, electricity and magnetism were unified by James Clerk Maxwell. And now, in 1978, 3 scientists realized that electromagnetism and the weak force were actually the one and the same at a very high energy level. And this force was unified into what's known as the please bear with me. Weak force. Electroweak. And then they went even further and they came up with a model known as the Standard Model. And the Standard Model realized that the electroweak force and the strong force were actually also the one and same at a very high energy level. And this became known as the Standard Model. Now you're probably asking, what about gravity? Well, as you know, Einstein and the theory of general relativity defined gravity. And as was shown earlier, gravity acts over an infinite distance because of the space-time continuum. Everything is affected by gravity. But then, why can't we unify gravity and the electroweak and the strong force all together in one? Well, gravity, unlike the other 3 forces, does not have a particle that emits that force. Now these 3 forces right here have what's called bosons. Bosons are particles that enact that force. And gravity, however, had no known bosons. Now scientists right now are looking for what's called a graviton. And a graviton would be that particle that carries the gravitational force. Now once that particle is found, hopefully scientists can unify gravity with the other 3 forces. However, as it is right now, we have 2 separate branches of physics. We have general relativity and the Standard Model. Now this ball right here is an example of matter. We know that this matter can be subdivided into atoms, and those atoms can be further subdivided into subatomic particles. And those subatomic particles, as we said earlier, can be subdivided into quarks. Now string theory takes this idea one step further. String theory basically says that quarks are made up of an even smaller ingredient. And that ingredient is a tiny wiggling strand of energy that look like a string. And that is where the name comes from. Now, these strings are unimaginably small. Now, if we enlarge a single atom to the size of our solar system, this string right here would be the size of a tree on our planet Earth. That's how small these strings are. Now, just as we create vibration and musical notes, say for example I play a G note, the different ways these strings vibrate give particles their unique property, such as charge and mass. Now, if our entire universe were, assuming that the theory is true, if our entire universe were composed of tiny little strings, just imagine our universe as a giant symphony of different vibrating strings all throughout the universe. Now when we look at these strings at the atomic level, we realize that all the forces that occur in the universe, the 4 fundamental forces, gravity, electromagnetism, the strong and weak force, are all carriers the string is the carrier of that force. And so this is how string theory unifies the 4 different forces. They show that at the string level, all these 4 forces are exactly the same, and that the carrier of this force are these little tiny strings, these little bands of energy that interact with particles of matter. Today we talked about the 4 fundamental forces that occur in nature. We talked about gravity, we talked about electromagnetism, the strong and weak nuclear forces. And we've also talked about the fundamental basic building block, the matter, which is made up of quarks. And we've also talked about 2 theories that are currently in existence, trying to explain everything that happens in the universe. We talked about the Standard Model and the string theory. Now you're probably wondering, is there exactly a grand unified theory? Well, no, there is not. But right now, the string theory and the Standard Model, good lord, are both trying to explain the occurrences in our everyday universe. So all I can say is, God bless, good night, and happy physics, honey. Mike, is there any way we can decrease the weight on this thing?
No. That's the lowest one.
Are you serious? I'm basically using this bad example right here. A baseball player swinging at a baseball and swings so hard that the bat cracks in the individual pieces and the ball, whoop, and I dropped it. The ball breaks up in its individual. I messed up. We talked about the 4 different fundamental forces. Alright, ready? Forces. And we've also talked about the fundamental basic. Alright, here we go.